This lesson is about the extended product rule. So the extended product rule is the product rule on steroids because that's what everyone needs. It exists. You don't use it very often because usually the questions don't get this large, at least not in calculus and vectors. It also probably won't happen in your first year of either college or university calculus. So I'm going to put this on regular screen and go over this. So the extended product rule is when you have a product of three or more functions. The product rule was when you had two functions. So if I flip back to the product rule, which I saved here, here are two functions being multiplied together. In the extended product rule, you have three. So you've got an f at x times a g at x times an h at x, or whatever you personally call them, to build to a bigger function. So this is just more. It's the product rule extended. So to take the derivative of the bigger, the larger function, you take the derivative of the first piece of information and multiply it by the originals of the second two, plus for product rule, the derivative of the second piece of information multiplied by the first and the third regular, plus the derivative of the third multiplied by the first and second. And if you have fourth, you just continue, fifth continues, sixth, and so on. Like I said, it usually doesn't get this large. So here's a question, or here's the English translation of the textbooky stuff. So the derivative of the first multiplied by the original second and the original third, plus sign, natural break if you need to drop down a line. Derivative of the second multiplied by the original first and original third, plus the derivative of the third multiplied by the original first and the original second. So we're doing 1, 2, 3 questions. I've started this one just for hand cramping. So it says use the extended product rule to differentiate. So that means take the derivative. And you would hopefully not need the instructions to use the extended product rule, and you could just see differentiate because you've got 3 pieces, which is more than 2. So if you're slicing them, there's the first before my wiggly line, there's the second between the wiggly lines, and the third after. So you're containing the exponent in the term, or in the piece of information, the mini function. So off here to the side, I did the originals and derivatives. So here's f at x, and I took the derivative using the power of a function rule. So drop the 3, keep writing, make it a 2, go inside and take the derivative of this, which is 1, clean it up. Here's the second piece of information. No exponent, no power of a function rule. So that derivative is 1. Here's the third piece of information, back to power of a function. So when you take the derivative, you drop the 2, keep writing, make it a 1, go inside, take the derivative of that, tidy it up. So you can do this like this, just like we did in the product rule, but you could also not do all that stuff and just go left to right and figure things out. So this is how a textbook would lay it out. If you need to break it down because maybe you want to tidy, which is not a bad thing at all, simplify, then it's a really good strategy. So back to the extended product rule. Now that I've got all my bits and pieces, I can actually do the extended product rule. So just for fancying it up, dy by dx equals, and I'm going to do my stuff. So derivative of the first, that's this one, multiplied by the original second and original third, plus sign. I'm running out of space. I'm going to drop down a line. The derivative of the second multiplied by the original first times the original third, plus sign, I'm out of room. Derivative of the third piece of information, I'm choosing the tidiest form, multiplied by the original first. I think I paused there when I was doing it before too. And the original second. All right, let me just check my work. Derivative of the first times the second and the third plus the derivative of the second times the original first and third plus the derivative of the third times the original first and second. Okay, all good, I think. So now I don't have any cleaning up. Like I don't have any monomials in this section to make look pretty. And I don't have any monomials in this section. I mean, all I'd really want to do is multiply or erase that 1, which doesn't bother me in the least. And no monomials here. So now I'm going to try to do the factoring. And it's almost to your advantage to lay it out this way, because here's your comparison. This is what you're trying to figure out if it has anything common between the 3, because it must be common between the 3 this time. So I've got a 3, a 1, and a 2, so I can take a 1 out, but I'm not going to do that because my hand already hurts. X plus 1 is in all 3, so I'm going to write down x plus 1. I've got 2, 3, 3, so I can take out 2, minimum. X plus 4, here, not here, here. It's not common to all 3, so I can't write that down, but I do see x minus 3. 2 of them, 3 of them, 3 of them, so I can take out 2 of them. And then I have to lay down a square bracket. And I have to recompare to find out what's left. So comparing this to my original first chunk of information, I need a 3. I took out all of the x plus 1 brackets. I took out all of the x minus 3 brackets, but I need an x plus 4 bracket. Plus sign. I think I can manage to go across the page this time. I need a 1, which I'm not going to write down. I took out 2 of these brackets, but I had 3, so I need to write it down 1 to account for it. And none of these, because they match entirely. Plus sign. I need the 2. Oh, do you see my mistake? I took out too many of these. Crap. Refactor. And sometimes you have to do that, especially when you're on holidays. So, x plus 1. Oh, did you hear my stomach? Squared is the minimum. X plus 4. Not common. X minus 3. I lied. I can't take out 2 of them. I've only got 1 sitting here, so I can only take out 1, and then I lay down my square bracket. This is going to mean more work. Crap. So I need the 3 for my comparison. These match. I need an x plus 4. Oh, here it is. I need an x minus 3 bracket as well. Okay, that does not make me happy because this says FOIL. Plus sign. I'm not going to put down a 1. I need an x plus 1 bracket. And I need an x minus 3 bracket. Plus sign. Time to crush. I need the 2. I don't need the x minus 3 bracket. My x plus 1 brackets I'll need 1 of. And I need the x plus 4 bracket. Just barely fitting that in. Am I ever glad I color code? So, I'll have x plus 1 squared, x minus 3 not squared, bracket. I am going to go rogue down here, and I'm going to multiply all this foiling out without having to write all this out front for every line. So I'm about to foil like crazy. So I'm doing this FOIL first. So x squared minus 3x plus 4x minus 12, all in a bracket with that 3 out front. Plus, I don't have a number out front here, so I'm super happy. X squared minus 3x plus 1x minus 2 plus 2 FOIL x squared plus 4x plus 1x plus 4. Now I'm going to multiply this through. So 3x squared minus 9x plus 12x minus 36. Same stuff. I'm going to collect a little like terms there. Plus 2x squared plus 4x plus 2x plus 8. So multiplying that out, just a little collection in there. So now I'm going to collect like terms. Whew. 3x squared, 4x squared, 6x squared. Negative 9 plus 12 is 3. Minus 2 is 1. Plus 10 is positive 11x. And negative 36 minus 2 is negative 38. Plus 8 is negative 30. And if you can factor this bracket, you're supposed to factor that bracket. I am going to leave it because I actually don't think it's factorable. And that is the derivative. So that is the formula for the slope of the tangent, which, I mean, this is terrible. It's a lot of work, but it's way better than doing limits. And it's really the shortest way of finding the slope of the tangent if you need it. And you will need it for later on in this course. We just start with a bunch of rules and getting you to do things and then give you a reason for it later. So here is the second question. I'm going to take a little hand cramp break and I'll be back with you. So back to this one. Did anybody catch my mistake? Come on. You're supposed to yell at me through the computer. It's right here. When I FOIL out this bracket, I get x times x, which is x squared, x times negative 3, which is negative 3x, positive 1 times x, which is positive 1x, positive 1 times negative 3 is negative 3. Sheesh. Now, that doesn't change much. I wouldn't recommend doing a question like this, meaning don't try to correct this way, just restart if you find a mistake. But it means that I get to dig out my eraser and the constant is what will change because negative 36 minus 3 is negative 39 plus 8 is negative 31. Still not factorable, I believe. All right, let's try second question and see if I can not mess this up. I'm going to go sideways here just to kind of maybe cut down on my space. So f at x, so I can't use f at x for this, g at x for this, h at x. So I'm going to use PQR just for fun. So p at x is equal to x squared. Q at x is equal to 3x squared plus 4 squared. And r at x is equal to 3 minus x cubed, all in a bracket with a fourth. So I'm slicing it here and slicing it here to notice there are 3 functions making up the larger function. So now I am going to take the derivative of each. Notice how I said I wasn't taking the derivative, and now I am taking the derivative, and I'm communicating that to you. So this is 2x, no power of a function. That's kind of awesome. Not so awesome. Drop the 2, keep writing, make it a 1 less, and then go inside and take the derivative of that. And the benefit to breaking it down like this is that you can clean it up and have less work in the long run, less writing in the long run. Another power of a function. Drop the 4, keep writing, make it a 3, go inside, that's 0, minus 3x squared, monomial, so negative 12x squared times 3 minus x cubed cubed. All right, time to put this together. F prime at x. I might be able to pull this off in 2 lines. So let's be careful here, as in, let me be careful. Derivative of the first times by the original second and original third plus sign. Derivative of the second times by the original first and original third plus, I can start, but I don't want to break in the middle, so I'm going to break here. The derivative of the third times the original first and the original second. So here's my monstrous plus sign, and here's my monstrous plus sign. And I'm going to clean up the first, second, and third pieces because I see some monomials in there. So unfortunately, this part before the first plus sign doesn't have any monomials, so it's almost like I'm wasting my hand crampedness. Plus sign. Monomial, monomial, so that's 12x to the 3. And then I'm going to follow a tip I gave you before. I'm going to put this bracket first. Yes, it's first, so I don't have to think hard about that. And this bracket second, so I mimic what I have at the very start. Now, I'm not going to put that plus sign down because this negative sign is a plus minus. So now I have a subtraction sign. I'm going to make it giant. Make this giant. And I've got negative 12x squared monomial times x squared is negative 12x to the 4th. And then this one matters. Here I'm going to do the 3x squared plus 4 to the 2. And then put down my 3 minus x cubed sitting there. And now I have to compare this chunk of information, this chunk of information, and this chunk of information for common factoring. And hopefully I can do this right this time. So monomial-ish information. 2x, 12x cubed, 12x to the 4th. I can take out a 2x. Bracket. Next thing, I see a 3x squared plus 4 bracket in every one of them, so it's common. And I have to very carefully take out the minimum. So 2, 1, 2, I can take out one of them. And then next up is the 3 minus x cubed bracket. 4, 4, 3, I can take out the minimum, which is 3. And now in a bracket behind, I take all this stuff and compare to see what's left. So gone, I need one of these and one of these. So I needed those brackets. Plus sign. I need a 6x squared, because if I'm taking 2x out, I need none of these, and I need one of those. Minus sign. I need a 6x cubed this time. I have one of them out front. There were 2 here, so I need another one to account for it. And I took all of those out, so I'm done. So just like the last question, I'm going to take this and I'm going to more carefully FOIL it out so I have a bracket remaining. And beforehand, I am going to write all this stuff down and be prepared for my collecting like terms. So green, going rogue. 3x squared times 3 9x squared. 3x squared times negative x to the 3 is negative 3x to the 5. 4 times 3. Whew. 4 times negative x cubed. 6x squared times 3. 6x squared times negative x to the 3. Negative 6x cubed times 3 x to the 2. And negative 6x cubed times 4. Collect like terms. In any order, technically, so negative 3x to the 5, negative 9x to the 5, negative 27x to the 5. Negative 4x to the 3, negative 24x to the 3 is negative 28x to the 3. Positive 27x to the 2 plus 12. Now I'm not done, but I need a hand cramp thing. Plus I want to show you one more thing that could happen to this, as in an or, meaning an alternate answer. So give me a sec to uncramp my hand. All right, let's give you an alternate answer, an or. So this is a choice. You might see this in a textbook. That's why I mention it. And I don't want you to go to a textbook and wonder why your answer is wrong when it looks different. So what you can do with this bracket is our highest power is has a negative value. So what I'm going to do, oops, not what I intended. What I'm going to do is I'm going to dig out my blue pen, and I'm going to go through here, and I'm going to change all the signs. So this will be positive as a start. This will also be positive. This will now be a negative term, and this will also be a negative. So basically I common factored. I can't common factor any letters or any numbers out of all 4 of these, but I can common factor out a negative 1, in which case the negative 1 would sit there. And then all the other brackets remain the same. So that is an alternate answer that you may see and may have to deal with and not assume you're wrong every time. All right, last question for extended product rule. Whew. So this time I'm giving it to you for a purpose. Determine the slope of the tangent line. So that word right there says, please take the derivative. So I'm going to take the derivative. I'm going to do this the way from before. And again, I can't use F, G, and H, so I'm going to go back to the P, Q, R. I'm also going to go over that again. So green pen. P at x is equal to 2x. Q at x is equal to x minus 1, x plus 1 squared. And R at x is equal to x squared plus 2x plus 1 all squared. So derivative time, sneeze time. Give me a sec. I actually think I have too many plants in my living room. Should get a spider plant. They apparently clean the air. All right, derivative time. I think that's why I'm sneezing. 2. That's simple. Sorry for my chicken scratch. Drop the 2, keep writing, make it a 1, go inside, take the derivative, clean it up, because it's probably a good idea to clean it up there. And r prime at x, the third one, drop the 2, keep writing, make it a 1, so invisible exponent, and this is going to be a binomial, so 2x plus 2, done. So yes, this is factorable, but I'm going to leave it. So time for the derivative. Yes, I know I have completely overlooked something. Doesn't matter yet. Derivative of the first times the original second and original third plus derivative of the second times the original first and original third plus derivative of the third. Wow, I'm glad I dropped down a line. Times the original first and original second. Now, if you want to, you can factor this. I'm certainly going to clean it up. And the reason I'm going to clean it up is because monomial, 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 monomial. It's worth me cleaning it up. So, this is the part that drives me crazy, in that I have a whole lot of repeating to do without any math. So 2 times 2 is positive 4x bracket bracket plus 2 times 2. Let's see if I can force this in. 4x bracket bracket bracket. So this question is different. You can knock yourself out factoring this if you want. It is totally factorable. You can group off red, 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 do your comparison, recompare, get an answer. But I want to look at the fact that this says that. So at any time after I've actually completed the extended product rule, whether it's here or the line where I clean things up, I can actually put in x is equal to -2. So this is going to actually take me a little bit of time and space, but all it is bed mess and a little bit of reading my own handwriting. So x is -2. Change of colors just for fun. So I am turning all my x's into -2's. And I'm going to have to drop down a line, so I'll do this in 3 parts. So 2 bracket -2 plus 1 squared. I need layered brackets, so -2 squared plus 2 times -2 plus 1, all in a bracket squared. So this x turned into a -2, this x turned into a -2 with brackets around it because it's squared. This x turned into a -2 plus sign. I'm out of space, so I'm going to go on and do -2's in here. So 4 times -2, -2 plus 1, bracket, -2 squared plus 2 times -2 plus 1, all in a bracket squared, plus third time's a charm. 4 times -2, -2 squared plus 2 times -2 plus 1, not squared this time, another square bracket, 2 times -2 plus 2, -2 plus 1 squared. So now it's bedmass time. Whew, I'm going to try some of this in my head. So let me know if you can't follow, because I'm hopefully going to talk this through well enough. So 2, that's that one. -2 plus 1 is -1. -1 squared is 1. -2 squared is 4. This is -4, so now I have nothing. Plus 1 is 1. Squared is 1. Plus sign. I'm going to do 4 times -2 is -8. -2 plus 1 is -1. Negative 2 squared is 4. Minus 4 again is 0. Plus 1 is 1. 1 squared is 1. There's 4 times negative 2 again, so I'm going to write negative 8. Negative 2 squared is 4. Minus 4 again is 0. Plus 1 is 1. Don't need to square that. Negative 2, or 2 times negative 2 is negative 4. Plus 2 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 squared is positive 1. So this is 2. This is plus 8. Plus negative 8, positive 16. So I end up with 10 plus 16, which is 26. So the question asked, after all that, determine the slope of the tangent line, not equation, so I don't have to do y equals mx plus b. So I now have my mtan, which is what I was after. You could do this using limits, which would be far more awful. Now to explain this. So I'm going to re-explain how to determine the equation of the normal. So first of all, the equation means I'd have to dig out y equals mx plus b. I'd have to find a y by subbing that into the original. And let's go over how to find the slope of the tangent. Sorry, slope of the normal. If I have the slope of the tangent, the slope of the normal is flip that upside down, make it the opposite sign. So then you could start your y equals mx plus b. So the work from the textbook this time is very little, even though you're looking at this thinking, giant, giant list. These two pieces of information in numerical order, as opposed to yesterday where they were unnumerical, this is the product rule again. This is the extended product rule. So you have very little extra new stuff, just a little reprieve. It lets you practice the product rule. It lets you practice the derivative rules. It lets you practice the power of a function rule, and just a little bit bigger. So that's that. We have another rule to go over, and that is the quotient rule. So I'll be back at you maybe today. I'm finding that I'm a little bit tired of making videos on my break. Yeesh. So talking to myself in my living room. So I will be back at you at some point in the next 24 hours, depending on my energy level. See ya.